Greetings, and we'll start with EDA hands-on today. So what we'll do is we'll quickly try to revise what all things fall under EDA. And before EDA, we need to understand that once the business requirements are clearly understood, once we have objectified the problem statement, and once we have benchmarked on what we need to do, we have to try and define a specific objective which can be measured in such a way that we basically have some user acceptance. We set the context on specifying what kind of results we are going to obtain, and we define certain benchmarks, and we try to measure the success in meeting that benchmark. And post that, we try and understand what kind of data the business is dealing with, what kind of tools and technology the business is dealing with, and then we try to identify what are the relevant features that are required to solve that specific problem statement that we have objectified. And then we try to get the data, right? We gather that data, we ingest that data into our environment. And once the data is coming in, we now start doing some statistical analysis using these concepts that we discussed, which are part of EDA, preliminary analysis, or we also call it as exploratory data analysis. Here, we try to get the definition of the data in an univariate analysis mode. That means we take one column at a time and then try to perform these analysis. And here we talk about measures of central tendency. This was the first thing that we discussed. And in measures of central tendency, we will have mean, which is also known as average. But mean gets influenced by extreme value. So we have median, which is the middlemost value. But these two are applicable only when we have numeric value. If we have non-numeric, we cannot do any computation. So we go with mode calculation, which is basically looking at the value which is repeating more number of times. Then we have measures of dispersion. Here we are talking about the spread in the data set with respect to the center. Center by default is the mean, statistical mean. Before I forget, we have also discussed about weighted average as well, right? Expected value. So if we take that as a reference, then we try to also see how the data is varying from that representative value, which is the mean. And here we basically look at the range, which talks about the boundaries, maximum and minimum. Then we have variance calculation, which is to measure the spread on an average for each data point, which basically is nothing but the squared distances average. Without squaring, we will eventually be getting the value as 0, right? When we try to measure the differences, summation of the differences, it will tend to become 0. Hence, to remove that negative values, we square it. But interpretation becomes completely wrong because we are squaring the values. So what we do, we take square root of variance, and this is how we represent the variation. Standard deviation. Formulas are very, very important. Dedicate at least 1 or 2 pages specifically in your notes for writing the formulas and practicing on them. Okay, in a neat manner, you probably can write these formulas. All of these are something that you should be able to easily interpret them. But there are a bunch of formulas which come into the picture, and it's handy to have a dedicated page for writing these formulas. Then moving on, we have shape statistics, which is nothing but your third moment and fourth moment. Both together are called as shape statistics because they try to represent the distribution of the data, again, spreading the data. But the interpretation always happens by visually interpreting the spread. So here we are looking at the skewness, which measures the asymmetrical nature in the data with respect to the center, whether the data is spread more towards right side or more towards left side. Extreme values is something that we try to figure out on the left side or right side. Then we have the fourth movement, which is kurtosis, which measures the overall spread of the data from the center. Here we try to see whether data is more closely aligned with the center, or is the data more spread out in the entire range that we have given for the data. So these are the four business movements that we have discussed. And then we also have data visualization standards for visually interpretation of the data distribution. Data visualizations. Again, we call it as univariate analysis. Here, EDA basically is nothing but we try to understand each column or variable separately. So we call it as univariate analysis. If I want to perform analysis by considering two variables together, because there could be some relation between them, so that is called as bivariate analysis. We'll talk about that also. And then anything which is more than two, we call it as multivariate analysis. So here we are only talking about univariate analysis to start with. We discussed about bar plot, where each data is represented using bar. The magnitude of the data is represented using bar. And bar plots are more designed, more suited for discrete data or count data, which basically has a smaller data set, right? Small data sets. When we have large data sets, then squeezing those values, large number of records into the space, x-axis space that we are displaying on screen, would show the data very, very congested. So we try to group the data and then try to project it, and that's histogram for us. Histogram is also known as frequency distribution because we will take the total data points, the number of records, because the challenge with bar plot is when data points are very large. So what we do, we take that entire count and then distribute that into bins, groups, or intervals. You either call it as bins or intervals or groups. The size of each bin can be controlled in the histogram depending on what kind of analysis we are providing, thereby coming out with the number of bins on the x-axis. The advantage of histogram is that it basically discretizes the data, even if you have very large continuous data as well. And it represents these huge amount of data into discrete bins, discrete data bins. The other advantage is that by looking at histogram, we will be able to also understand data distribution. Skewness can be interpreted using histogram. Skewness and of course kurtosis can be easily understood by looking at the data using histogram. Then the most important visualization, box plot, and this is the speciality of the box plot is it is the only visualization which visually represents if we have outliers in the data set. Not all extreme values are outliers, remember that. And we need to learn how do we deal with these outliers. So we call it as outlier treatment or outlier analysis. So if you see outliers, how do you deal with it, right? That is the scenario that we will have to look into. But in the first place, how do you see outliers in the data set? How do you define a data point as outlier? Outliers are nothing but extreme values. And we put a cutoff mathematically using a formula. We create boundaries or a cutoff, and we define this boundary using a formula called Q plus or minus 1.5 times of IQR. So the box plot uses this formula to visually represent the outliers in the data. And of course, it is specifically used for numerical data points because we need to compute the boundaries, and then we have to visually show the outliers and all that. Outliers come into picture only when you have numeric data. There's no concept of outliers for non-numeric data. Remember that. So these are the things that we discussed. And remember one thing, any data set that is given to you for analysis, irrespective of the business problem statement, we will get data set. Data set means nothing but table, okay? Fields arranged in a table representation. In Python, we call this as a data frame, right? In SQL, we call the same thing as table. So once you get this data set, always remember, we try to take one column at a time and then perform the EDA, understand what does this data speak about. When we try to understand it, we have to map it or align it with the business operations or business standards and see if there are any interesting insights that we can find out. For every column we do it, right? Hence we call it as univariate analysis. Now you might say, what if I have 10 columns in a data set? Fine, right? It's probably something which is easy. 10 columns is not big deal. We first, of course, identify whether it is qualitative, quantitative. Then we identify whether it is discrete or continuous. Then we identify whether it is nominal, ordinal, interval, or ratio. And post that, we perform these statistical computations. So interpretation happens this way. Now, if I have 10 columns, we apply the same. If I have 2 columns, we apply the same strategy. Even if I have 100 columns, we have to apply the same strategy. Without performing EDA, we cannot go further. And remember, the business understanding and the data understanding, right? 1A, 1B, and then the next stage, which is data pre-processing, right? These two phases of your CRISP MLQ methodology is going to consume around 60 to 80% of the entire project time. If the entire 6 phases you have 100% effort, then 60 to 80% goes here itself. And that is the reason why we are spending more time. Though it seems very trivial, we are spending more time just because of this reason. You cannot proceed to further steps in CRISP MLQ without performing these steps thoroughly. Okay, remember that. Very, very important. Now, I mentioned if it has 2 columns, if a data set has 2 columns or 10 columns or 100 columns or whatever that number is, we have to perform univariate analysis to start with. Then we go for bivariate analysis. Then we go for multivariate analysis. This, and of course, part of it is nothing but your EDA. And this is your descriptive analytics using ML. Okay, advanced mathematical computations is what we start with. This is how we proceed. Okay, so we are at this stage. So what all things we are doing? 1, 2, 3, 4, and then these visualizations. 1. Every column we do that. Whatever is relevant, whatever is irrelevant, you can ignore that and record the findings. But this is time consuming. It is laborious and it is time consuming. Absolute. And that is where the ML, right, community, the data science community, you can say, people have brilliant ideas. So some of them have started working on how do we automate this process, because it is a repetitive process. Anything which is repetitive can be automated. Remember that. So we have something called as auto EDA as well. Auto EDA basically means it performs these 5 steps. Of course, there are a few more things which are iteratively performed on each column of the data set by a single command. Automatically it does that. It's very simple. Logically, it is very simple. I have for loop. We have learned loops, right, in Python. So just imagine that we have a for loop. We will take first column. identify whether it is qualitative, quantitative. Based on that, we try to perform respective EDA. If it is qualitative mode, if it is quantitative, perform mean, detect outliers. Then we basically calculate variance, maximum, minimum, skewness, kurtosis, then visualizations, right? Like that. So once this is done, we go for the next column, for loop, right? First column, second column. Even if I have 1,000 columns, no problem. It is automatically going to perform all this and generate a single report. We'll talk about this. In fact, I, along with one of my student, we created our own auto EDA library as well. Okay. Where are these libraries located? If I have to ask you people where these libraries are located in Python, what is the location? Python libraries.
PYPI.
Yes, pypi.org, public repository. Okay. All right. Now, let us try and implement these 5 steps on some random data set that we take in Python. So assume that I'm giving you a data set. Then what is the first step that we do in Python? What is the first step that we do or we should do? I give you a business problem. I'll explain about the data and I'll give you the data. You have data in an offline file to start with. It is a CSV file. Okay, data is available. Now what should we do?
Import the standard libraries that are useful.
Very good. Import libraries. Very good. Then
declaration part where you'll have the variables or the functions that are required to perform certain action.
in Python, we don't need that. Declaration is not required. The next one is get the data. Load the data. Okay. So these are the standard steps. Import libraries, get the data. From here on, your EDA starts. First movement, second movement, third movement, fourth movement. And all of these are very, very simple functions. Let me show you that. Good. So here you can see I've imported the required library and loading the data. You can copy the path of the file, and in Python, we can either use this backslash or forward slash. Okay. This is your forward slash and this is your Windows style backward slash. We can either use this or this. Then understanding the data set, you can simply say info and it gives you the data type information, null information, etc. And then we have very simple, see, first movement, very simple. Then here we have second movement, third movement, fourth movement, right? That's all, very simple functions. And here we have visualizations. Again, I'll load the data. This is the required library. And of course, this is also required. And then we come up with bar plot, histogram, variations in the histogram by changing colors, etc. Then we have histogram using Seaborn library as well. And then we have boxplot. We also have additional visualizations like density plot is there. Then we have describe function, which basically gives us the entire breakup of your EDA components. And then here we are talking about bivariate visualization also. Right? So very, very simple. I'll basically take a new sheet and see what we are doing. Once again, we are basically trying to import the data, right? And then perform the EDA one step at a time, right? So let us do that. First step is import library. What is the required library? If I have to import the data set, then I'll have to say import pandas. If you want to give alias to it, yes, go ahead and give it. If you feel that no, alias is not required, then we can ignore the alias. I'll say as 3D. I want to give it. It's a standard practice that we do. Now, we need to look at the data files. So here I have data sets. There are two files. I will take shopping mall data set sample. So it contains customer ID, people who have visited the shopping mall. There, some basic information is captured without having their personal information directly right providing here. We basically have customer ID, a unique identity given for each customer, their age, their income, expense, and the gender. I've specifically arranged it this way because this is categorical data, right? So I have 1, 2, 3, 4, 5. 5 columns to start with. Now, interpretation, quantitative, 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 and this one is qualitative. So if I break it, 4 numeric columns, 1 non-numeric column, categorical column. Next, customer ID, discrete, age, continuous, income, continuous. What is this? Expenses score. Score, any score can be also be given in decimals, right? It's our choice. So we need to properly identify what is this expensive score by understanding the true meaning of this, the range of this, and the possible values of this by talking to the data experts in this business scenario. Who has whose idea is this expense score? What does its true meaning is? What all values it can take? You need to understand that information to identify whether it is continuous or discrete. Without that, whatever your interpretation would be your assumption, right? And we cannot go blindly with assumptions. So business understanding and data understanding comes from that, right? Data description as well. So what I see is all numeric values. So I'll write it as discrete. That means I'll have a range of values probably from 1 to 100, assuming. Then again, gender is discrete. Next, measurement types. What is customer ID? What measurement type is customer ID here? Yeah, friends. Scales of measurement. The first column, customer ID, what is the measurement scale? What all values we have here in measurement scale or scale of measurements?
Nominal, ordinal.
Yes, nominal, ordinal, interval, ratio, right? So these are the 4 scales that we have. So what is customer ID? Is it nominal? Is it ordinal? Is it interval or is it ratio?
Nominal.
Nominal.
It is nominal. That's right. It is nominal data. Right? It is just an identity for each customer. Next, what is age? I can clearly say that it is numerical value representing age of each customer. So it can either be interval or ratio. It cannot be nominal or ordinal. So what is it? Is it subjective value or is it objectified value?
Interval.
The interval means it is subjective. Ratio means it has its true value, right? It is objectified value. So when you say age, a person's age is 19 years. Is it subjective?
No.
No, right? 19 years means 19 years anywhere, whatever the context is, isn't it? So if I say the person is elder or older, if I try to rank them based on age, then it becomes interval because I'm defining a specific value to give some measurement to that age within this context. But this is not within the context. Hence, it becomes a ratio. Okay, this is how we interpret. It has to be global value. The meaning of this value should be globally accepted. Okay, that's ratio. Then income. Is it interval or ratio again?
Ratio.
Ratio. Income is income anywhere. We are not putting any units here. We are not comparing the pay scale here, right? So it is basically ratio. What about this expense score? Is it ratio or interval?
Interval. It is subjective. It is a score
Yes.
based on.
Perfect. So this score that we are seeing is specifically given to each customer within this shopping mall in the context of this business scenario, right? So I cannot take this expense score and interpret that in a different business context. It doesn't make sense there, isn't it? So this becomes interval data. And then we have gender. Gender is non-numeric data. So by default, what it will become? Either ordinal or nominal. What is this?
Nominal.
Is it? Yeah, it is nominal. You cannot give any preference to the gender. This is the interpretation that we start with. Okay, now, should I be really performing any EDA computations on customer ID? Is it required? For nominal data, which is used as an identity here, which is of course a numerical value, should I be performing any computations on this? Yeah. What all computations can be performed on nominal data?
Sorting. No
Sorting.
sort. Not sort.
Just the count.
Count.
Yes, only count or proportion or frequency or percentage, right? Only count based computations. But this customer ID is numerical representation, right? Sequence number. Can I not calculate average? Can I not calculate minimum value or maximum value? Cannot identify that. Can I not calculate range now because I know these two? Can I not calculate variance because I know average also? I can perform all these computations, but does it make sense if I do these calculations on customer ID?
No.
No, right? That's the interpretation. Nominal data, even if it is numerical data, there is no meaning to these computations. So you can safely ignore this for EDA. Next, age. Age, yes, it is very important feature and it's a numerical ratio data type. So we can perform all the EDA computations. All the 4 EDA computations will also be able to visually interpret this data. So what is the first thing that we do when I see age column for this shopping mall? You are the management of the shopping mall, and what is that you want to find out?
Average.
Yes. What are the kind of people who are visiting the store? What is their average age? Right, to start with. Average age, because that is a representation of the entire customer base. Then I want to also understand whether more male customers are coming or more female customers are coming. But here I cannot do mean calculation, so I'll have to go with mode calculation. Similarly, what kind of income range people are coming in? So all these are basically your first moment business decision calculations to start with. Right? So let us try and load this data set into this, and then we will try to compute our EDA calculations. So I'll say DF, short for data frame. You can also give any other name you wish. I'll say pd dot read underscore CSV. Okay, this is the function that we want to give, and then we have file path. If you want to see all the functionalities of pandas, then we will say dir of pd, right? Remember this function? It gives us the, sorry, I have not imported this. First, I'll have to import this. Once it is coming here, then I'll say dir, it goes to the memory and then gives me the list of all the modules that we basically can use here. And because we're talking about a CSV file, this is a CSV file, right? So we are using the relevant function. I'll copy the file path. You can either say copy as path or just the file. And then here, inside the bracket, you mention that. Okay. And we have to, of course, put the quote, either single quote or double quote. There will be certain cases where the location, the path that we are talking about, that particular file, may contain spaces like this or may contain special characters in the path. In such case, if I'm using the standard Windows location, so if I click on the address bar, what is the slash that I'm seeing here? This is the backward slash, right? This is called as backward slash. Windows has this syntax. I can also use this location as well. Okay, I mean backward slash. But by default, you will get forward slash when you take the file copy as path option. If you're using Mac, then also you'll get the forward slash. Linux, anyways, the standard is forward slash. Okay, but if in Windows, if you're using, then you have to be a little careful, especially when you have certain special characters. So, for example, slash D has a specific meaning, digits, right? And then slash S, slash T, slash N, these are having specific meaning in English dictionary or English language, right? From computer terminology perspective. So we have to be very, very careful. And what we can do in such case, right? I'll say df1 is equals to, I'll just show you pd dot read underscore CSV. And then if I put the location along with the file, I'll have to put it. This is only the directory location, right? I can put the path like this. Okay. When I do this, in some cases, I'm not saying it is always going to happen. In some cases, you get error. Here, in this case, it did not read any error. It basically read the data frame properly. But in some cases, you may have certain challenges. For example, I'll say dollar. I'm assuming it. See, when I put special character here, immediately it says the directory is not able to read. It says no such file or directory because this folder does not exist. Even if the folder exists, this is the error that you get. Okay. If I have, for example, a location like new trainings, if this is my folder, assume, even in this case, you will get some kind of an error because it will not be able to interpret this location properly. To overcome this, what we do? We put R symbol in front of it. This is specifically for Windows users, right? Not for Mac or Linux users. There you don't have these kind of issues. Okay. We can also put double slash like this. This is another way where we can try and read the data from our locations. Manually, these are the things that we'll have to do if you want to, right, follow the default location. So I'll remove this R and then I'll read it. It works here. No problem. I can also put R symbol. R means raw format. Okay. As a general practice, I personally use R anywhere. If I'm using in Windows, I by default put R symbol. But as I said, not required. If I use this, directly I'm able to load the data set. Okay. This is our Data 200 rows are there, 5 columns are there. This is my data. In order to understand the overview of the data, I will say info. This gives me the breakup of our data set. 200 entries are there, that means rows. This is the index. These are the columns. I have total 5 columns. Column ID is given here. Column name is given. Non-null values means I don't have any null value because everything is 200. And these are the data types. So 4 integer data types are there and 1 object type is there. Object is nothing but your string data. In a data frame, it is represented as object. Okay. So this is basically how we summarize the information about the data set. It also gives us how much memory did it consume when I'm uploading this file into the this particular session's memory. Okay. All right. Now, what we need to do is identify the first moment business decision. Right? We need to calculate the first moment business decision. So I'll say first moment. In first moment, what all things we have? Mean, median, mode. Statistically, it is always mean that we have to go with. All right. Now, how do I refer to the object here? My object in sessions memory is df. I can only understand df. Okay. So I will say df. It shows that this is a variable, right? But within the data frame, I have a specific column that I want to refer to. So I'll put dot and then I'll say the column name. This is my column name. Then what is that calculation that I want to do? First moment, it's a very simple English language. So I'll say dot mean. So data dot function. Very simple. This gives me the average calculation. You can also do the same calculation here. You can probably use Excel to look into that. Average of this is 38.8. That's what we do. Now, if I have to do median, what should I do? I want to know median age. What should I do? What do you think is the function? Simple. Come on. DF.
Age or median.
That's all. Similarly, if I want mode, I'll say mode. Simple English. This gives me median and this gives me mode. And look at this. Mean and median seem to be slightly different. They're not same. That means there is some kind of asymmetrical nature in the data. There seems to be some kind of asymmetry. And median is 36. If I say median is the center value, 36. But what is mean? Mean is 38.35, 38.85. That means mean is always getting pulled towards the extreme value. So we have extreme towards right side. Okay, remember this point. So skewness is right skewed data. Is this really a right skewed data or not, or something that we will be identifying by calculating skewness and visualizing the data. Okay. Now, this is with respect to age. If I have to do the same thing for income, then what should I do?
df dot income dot mean.
So, simple, right? df dot income dot mean or median or mode. Okay. Very simple. Now, what if I want to calculate mean, median, or mode for all the columns? I don't want to do it individually. I want to do it for all the columns. That also can be done because see, I might have 10 columns or 20 columns. Should I be doing mean calculation, median calculation for each column separately? Not required. So what we can do is we can say simply df dot mean. Remove the column name. Okay. Now when I do this, initially in older versions, it used to give us results, but now look at this. Because we have one of the column which is categorical, the gender column is categorical, it takes all the columns into consideration and it is trying to do this calculation, and it says type error, data type. This is non-numeric, you cannot calculate average, right? So this error is coming. Now to overcome this particular problem, we need to put a specific parameter into picture. We are saying only consider numeric values, don't consider non-numeric values. So for that, we have numeric only is equals to, by default, it is false. It considers all the columns. So here what we are saying, true. We'll have to override that. That means you only consider numeric columns, don't consider this data type, which is categorical in nature. So it says customer ID because it is numeric, it is calculating that also. Of course, you can ignore this computation, but the remaining three, you can see the computation is completed here. Same thing I can do it for median also, because median also works for numeric data. But when it comes for mode, I don't need to do this because mode is designed to work both on numeric and non-numeric fields, right? It is basically capturing the most frequently repeated value. So we say mode is like this. So customer ID, I have each customer ID repeating once, more number of times, right? There is nothing maximum like this. Everything is repeated only once, which is maximum. So this customer ID is basically giving me a multi-model output. Each customer ID is a mode. But when you look at the age, 32 years is repeating maximum number of times. So you will only see uni-model value here. Whereas in income, I see 54 and 78. Both these values are repeating equal number of times and maximum number of times. So you'll have bi-model data for income. Similarly, expense score is 1 and gender is female is repeating more number of times. That means for this particular business, shopping mall, we have more female customers coming in. But how many of them are there in this particular data set? I want to also know the breakup. In order to know the breakup, we can actually do this. What is this column? This is the gender column, right? Let me see the column name. Yeah, gender in uppercase, properties. So this is my field, and here there is something called as value underscore counts. Now, when you say value underscore counts, it gives us that breakup. It gives me how many unique values are there, female and male, 2 unique values are there, and how many times it is repeated, the count of it. All right. So you see 112 and 88. I can apply the same function value underscore counts for numeric columns as well. Say, for example, I'll say age, value underscore counts. You can see 32 is repeated maximum number of times 11, but these are the other ages that we can see. Similarly, I'll do it for the next column, which is income, which is basically giving us bi-model data, right? So let us see this. So 54 and 78 repeated maximum number of times, which is 12. Both are same. Hence, it was showing us a bivariate, bi-model outcome. All right. So this is basically how we deal with the first moment business decision calculations. Now coming to the second moment. Now, when we talk about second moment business decision, What all things we have to do here in second movement? What all things are part of second movement? Once again. Yeah.
The variance or the standard deviation.
Measures of dispersion, right? So variance, standard deviation, and we
Range.
also have
Range.
range. Exactly. Range. For range calculation, what do we need? Minimum
Minimum.
and minimum
Minimum.
max, right? So again, same logic, I'll say df dot age dot minimum. This gives me minimum value. 18 is the least age. Same way, I'll say max. Range is nothing but maximum value minus minimum value. This gives me the range output. Now I'm basically not saving this value into anything. If I say R is equals to this, then the computation will be stored in a variable called R. A new variable R comes here and that value gets stored. You will not see that output. Here you see output, here you don't see the output. Right? So this is basically how we compute range. Very simple. But yeah, what do we need? We also need to see the variance and standard deviation. So once again, df dot age dot for variance. What do you think is the function for variance? For mean, it is mean. For median, it is median. For mode, it is mode. Okay, guess.
Variance.
No, people were lazy. And that is the reason why they did not say maximum or minimum. They said max or min. So variance is in short form, var. So VAR, that is the function. And for standard deviation, which is nothing but square root of this, the function is STD, standard deviation. Okay, you can try and do the square root of this. You'll get exactly this. Okay, so this is about your second moment business decision. Next comes the third moment. This is very simple. We basically say skip. Skewness has either positive value or negative value, right? And we observed median was 36, mean was more than median. That means it should basically be right skewed. That means it should be positive value. We are getting positive value here. Positively skewed data. Slight, it is close to 0, right? 0.5 if I have to round it up. Not much big number. It's very, very small, close to 0. That means very slight right skewed values are there. Then again, we will have the fourth moment, which is nothing but vf.h.cut. This is for cut losses. Here also we have sharp peak or wider peak, positive or negative. But this internally is computed by comparing with the standard value. That standard difference or standard is 3. So whatever the value that we get, kurtosis value that we get, we subtract it with 3. This is called as excessive kurtosis. Okay. So kurtosis function is x minus mu by sigma whole power 4. Okay. Expected value of this by 4 minus 3. This is what we've recorded. This is kurtosis. This minus 3 basically is nothing but your excessive kurtosis, which means it is doing the comparison with the standard And then it explains whether it is sharper peak or wider peak. Negative means it is wider. This is your mesocultic value. Mathematically, when you get the ideal symmetrical bell curve calculation, then we get kurtosis as 3, we compare it with that. So you're getting a negative value. That means the data has decent spread in it. Again, this is also close to 0, right? So close to 3. Kurtosis value is close to 3. That means it is kind of having a standard distribution, but a little wider compared to that standard. This is basically how we do the kurtosis implementation. Now let us see data visualization. So in the data visualization, the first one is bar plot, then we have histogram, then we have boxplot. To start with, the computer screen that you are seeing here, right? This computer screen is a bivariate visualization space, right? I mean, you can do a bivariate visualization. It's a two-dimensional space, isn't it? So when you have a two-dimensional space like this, then we basically have in bar plot, what do we have in like this? X-axis, Y-axis, right? So we will have to show what will be there on X-axis and what will be there in Y-axis for this particular bar plot visualization. And the default bar plot is always vertically aligned bars like this. The height of this bars would be your data. That means your Y-axis will take the bars. Okay. So we basically pass that parameter for Y-axis. But what do we have on X-axis? This is a single column, right? If I say age, it's a single column, right? But what we show here is there are 200 age values. There are 200 different ages, right? So that 200, which is the sequence number, will come here on the x-axis. So x-axis will be range of values ranging from 0 to 199 or 1 to 200. 1 to 2, not 1, sorry. This is 1 to 200. Okay, so this is how we get our x-axis and y-axis on bar plot. But in order to come up with this visualizations, we need the required library. The data visualization library is matplotlib. So I'll say import matplotlib. But in this matplotlib, we also have a subplot. Remember, we don't want everything. So we have something called as pyplot. We'll have to import this and give an alias as plt plot. I'll show you this also. I'll go to the specific location, Anaconda 3. I'll go for lib, then site packages. Okay, sorry. I need to go for nvs, in class, then library, then site packages. Here I go for matplotlib. Yeah, matplotlib. And I was talking about pyplot, right? Pyplot. As you can see, it is a simple Python file. This contains all the required visualizations. What we are trying to do is a bar plot, right? So let me search for bar plot. These are all color bars. Yeah, this is our bar plot. defined bar, right? So this way we can try and look at the specific bar plot or histogram. This is bar H. Bar H means bar plot, which is horizontally arranging your bars. By default, it is vertical. Bar H is horizontal bar. Similarly, I'll search for histogram. The function is hist. You can see directly hist function comes up. Box plot. Directly you're getting box plot. So rather than loading all the files from this folder, we only load what is required. PyPlot, we also have PyLab, which is also frequently used. In this case, we are importing PyPlot. Okay, so we have matplotlib, PyPlot. Okay, all right. Now let us import this. And as you can see, we're also going to come up with either range function or arrange function. Okay, let me first do this. I would say plt dot bar, and as soon as I give the function, you can see these options. X-axis, height is the y-axis. Then you can also define width, the alignment, the colors, the data, right? So many different options are there. I will be primarily using x-axis details and y-axis details. That is more important for me, right? So I will say x equal to range of 0, 200. This becomes my x-axis. Then y-axis, we will say height. It's not y-axis, it's height. Here, what is our data set? Our data set is df, and then the field that I want to visually represent here is age. That's all. When I do this, why is this? Oh, sorry, this is 0. My bad. It throws an error because my dataset size was 200 records, whereas when I said 1, 200, it was only taking 198 values, 1 till 199, right? That's the reason why this error came up. I'll plot this. So now there is no error, you can see, and the visualization comes here. The first visualization was errored out, so there was nothing here. Let me delete this. But yeah, this is our bar plot. By default, this blue color will come. Okay, by default, the blue color will come. Okay, now why should I use range? I can use arrange function also. So what I do, I'll import numpy, and in x-axis, I'll say np dot arrange and then execute this. Right? No problem, I'm getting the same visualization. First and second visualizations are same. All right. So this is basically how we can put it. If you don't want 0 here, you can put 200 and increase this to 201. This is your third visualization. All right. So that's all. That's the difference. Now we also have seen bar h. Right. So I'll say plt dot bar h. So here you can see you come up with a y and width. In bar plot, we had x and height. In bar h, we will have y and width. The variables locations change. That's all. Okay. So what we do, I'll just copy this, but here in place of x, I'll say y. And in place of height, I'll just copy the same thing. In place of height, I will say width. And I get the visualization which is like this. This is your bar plot. You will have to specifically pass the range that is required, which is based out of the number of records you have in the data set. You can change this to income and then try to see what is the distribution of your income. Now remember, for age, the data was slightly right skewed, but we will not be able to see it on the histogram because 200, sorry, bar plot, because 200 records are there, right? So what we do, we try and use histogram here. Histogram is very simple, plt.hist, that's all. And here we have to pass only one data. The x-axis is automatically considered. The bins will be automatically calculated. You really don't have to do anything to start with. But if you want to customize it, yes, you can do it. For now, what I'll say, df.h. When I do it, you'll see the histogram, and you can clearly see histogram is showing the right skewed behavior, right? So because of this, extreme values, right? Majority of the data is lying here, but there are extreme values here. Because of that, your median, which was 36, was slightly pulled towards extreme values, 38. But you can clearly see that it has right skewed data. Right? This is how histogram can be done. Now I can play around with histogram. You can see the details here. I'll come here. I'll click on this histogram list, right? So you can basically pass a lot of options. For example, if I want to show the histogram with colors, so what I'll do, I'll just take this and put comma and say colors. Color is equals to solid colors have to be given. I'll say red. So this is the visualization. You can also highlight the edges. I can say edge color. It's not coming, but here you can see. Okay, fine. Color type is there, right? Color. Somewhere you'll also see edge color. There are some parameters which are not defined here, but you can, right? You can see when I say edge color, it says star star keyword arguments. So we can add additional arguments also, right? So here I will say black, red and black. Now if I plot it, you can see the bins are given in the borders. Now we have seen the default widths here, right? We have not passed any width. But if I want to give any width, then we can always choose the bins. You can say integer values or sequence of values or string values can be given. By default, it is none that is taken. Right? So we have seen what is minimum and what is maximum. Minimum is 18, maximum is 70, right? So I can put, I'll put bins here. Bins is equal to. When I say bins is equal to, you need to pass list of values, multiple values, right? So I will say, I can also give only integer, which basically means I want 10 bins, for example. It gives me exactly 10 bins. If I say 20 bins, I need 20 bins. You can see more number of bins are coming. So this is with respect to number of bins. But if I want to pass specific bins, then I'll have to give value like this. Lower extreme, yeah, you don't need to pass anything. I'll say 18 to 30. Okay, from, okay, this is, I don't remember whether lower extreme is considered or not. Anyways, we'll try. We'll say 30, then I'll say 30 and 50 records are there. 80, I'll put 80 here. And then I'll say 100. What was the maximum? I forgot. What was the max value? 70, right? So I cannot take 80. I'll say 40, and then I'll say 70. Now let us try. Yeah, look at that. So, okay, lower extreme is not taken. So I'll have to put 18 here and then execute. So from 18 to 31 bin, 30 to 41 bin, 40 to 70 and bin sizes vary. All right, this is your histogram. Now, when you've seen the histogram with the default bin size, you could make out that it is a right skew data. But when I played around with the bin width of the bins, then the interpretation completely changes. If you observe here, it shows that it is left skew, right? So choosing the bin size is also very, very important to justify your findings. Why did you choose 10 bins? Why not only 3 bins? Right? So that justification is very, very important for your interpretation. Okay. Finally, the plt.boxplot, and for boxplot we have full name boxplot. And here also it's very simple. I'll have to pass numeric column. I get the boxplot visualization. And what you're observing here is a vertical boxplot, right? So what I can do, again, I can click here and come to boxplot discussion. This is the visualization that we were trying to understand on what is the outliers, right? This is the boundaries that we basically discussed. This is the IQ of the box region. And yeah, so we have box plot, we pass the values, and by default, it is coming as a vertical value. There is something called as vert somewhere, PERT, vert. Okay, yeah, look at this, vert. It takes Boolean values. By default, it is vertical, right? So here I would say vert is equals to 0. If I pass 0, then you get horizontal visualization. Okay, so these are basically our visualizations for the box plot. You can also add colors and all that you want. You just have to read the documentation, and then here also you have colors and other options. Experiment. These are the standard EDA computations that we have seen. The 4 business movements, right? First movement, second movement, third movement, fourth movement. Then visualizations, we have bar plot, histogram, and we have box plot. This histogram is a slightly different one. Let me show you this also. I'll run this histogram in Seaborn. So we'll have to import Seaborn library. And then I would say this is DF. Hist plot is like this. Okay. This is deprecated. That means it is no more being given. So you have to use this function, dist plot, or you can also use hist plot. So T is removed here. And when I do this, this is the histogram that we are getting in Seaborn library. Okay. Slightly different, but matplotlib is more widely used visualization technique. We also have density plot. We have the describe function. This is something that we'll have to also see. I'll stop after this. df.describe will give us the descriptive statistic computation values, the first moment, second moment, and the distribution computations. And this works only for numeric column. So what is the total count? Basically tells me if there are any null values, this count goes down. That means there are no null values. First moment we have computed. For age we have done that, right? Standard deviation is shown. Then it gives us the minimum, maximum, the median. 50% is nothing but median. First quartile and the third quartile computations are given. right? One single function does the computations like this. It gives us the breakup. Yeah. So this is about your describe function output. We can also try and see df dot describe. Yeah. Generate descriptive statistics. It basically summarizes the central tendency, dispersion, and the shape of database distributions. It excludes NaN values. So if you have NaN, it removes them. Okay. And it analyzes numeric objects by default. Okay. And object series also it can perform, but again, you'll have to basically pass those parameters that, yeah, when you want to do the descript for non-numeric data also, you'll have to pass those values. These are the parameters, but that means these are the outputs that we get. Okay. Attributes basically means inputs that we are going to pass for this function. Parameters are nothing but the output that it computes. And returns is the output that we are seeing on the screen. All right. So this is basically how the examples are also given for your computations. If I have a series data categorical, then it also gives you this described breakup. Okay, even for time series, it basically does that. If you have a time data, then also it gives you the breakup. Okay, by default, it works only for numeric fields. Okay, by default, only numeric values. If you want all, then you'll have to say include all. Then it does these computations, right? So when you want to try and apply any function, you can come to the help and go through the documentation. Majority of these functions, there is clear description of the functions, how to use, where to use, and right with data set examples are also given. If you don't find it here in the help, then you can go to the official documentation of this function as well by doing a Google search, simple Google search. Okay, there are a lot of open source platforms where you can have all this help made available for you. All right, so I will stop here. This is basically for EDA computations. And right, we'll connect tomorrow to discuss the next interesting concepts that we have to study. All right, I'll stop here. Thank you so much.